For this lesson, we're going to take a look at solving equations by factoring. And in order to understand solving equations by factoring, you need to understand the zero product property, which says if you multiply two numbers together and the answer is 0, that could only happen if either the first number was 0 or the second number is 0. So if you multiply two numbers together and the answer is 0, that means at least one of the original numbers was 0. Let's see how this works in terms of solving equations. Here we have two factors being multiplied together to give us an answer of 0, and that would mean that either this first factor was equal to 0 or the second factor was equal to 0. So now we have two little separate equations to solve. Here we'd solve this one by adding 2 to both sides. So x is 2. And here we would solve this equation by subtracting 5 from both sides. So here x is -5. And notice if we were to substitute the 2 in place of x here and here, we'd have 2 minus 2, which is 0, and 2 plus 5, which is 7, and of course 0 times 7 is 0. The same thing works if we substitute the -5 in place of x. We'd have negative 5 subtract 2, which is -7, multiplied by -5 plus 5, which is 0, so we'd have -7 times 0, which is 0. So both of those solutions do work. Here's another example. Notice here, instead of two factors, we actually have three factors. So we need to actually set each of these three factors equal to 0. So there's actually going to be three solutions to this equation. We have 5n equals 0, or n minus 3 equals 0, or n minus 4 equals 0. To solve this equation, we divide both sides by 5 and we get n equals 0. For the second equation, adding 3 to both sides, we'd have n equals 3. And then adding 4 to both sides here, we'd have n equals 4. So there's three possible solutions for this equation: 0, 3, or 4. This next example, we have a quadratic equation. The quadratic is not in factored form. Before we can use a zero product property, we actually need to factor this trinomial. And we have x squared, so we know we have x and x at the beginning of our parentheses. And here we're looking for factors of 24 that differ, because this is minus. We know that the factors have to differ by 2. So factors of 24 that differ by 2 are 6 and 4. And notice we have a -2 in front of our x. That means we want the negative to go with the 6 and the positive to go with the 4. You can do a quick check here just to make sure we do have a -2x as our middle term. We have 4x and -6x, and when you combine those like terms, you have -2x. So our two factors are x plus 4, so either x plus 4 equals 0 by the zero product property, or x minus 6 equals 0. And then we would subtract 4 from both sides, and here we would add 6 to both sides. So our two solutions are x equals -4 or x equals 6. I'll show a quick check here on the x equals 6 solution. Substituting 6 in place of x, we'd have 6 squared minus 2 times 6 minus 24, and we need to see if that really does equal 0. 6 squared is 36, minus 2 times 6, that's 12, minus 24, and we can see 36 minus 12 is 24, and of course 24 minus 24 does equal 0, so this definitely is a solution. And you could do the same thing with x equals -4. Let's take a look at another example. This one we actually have to do one little additional step before we can do the factoring. That is, we have to get 0 by itself. Remember, the zero product property says the two numbers multiplied together must equal 0, and we don't have a 0 here on the right hand side of the equation, so we actually need to subtract 35 from both sides of our equation first. And when we do that, we would get x squared minus 2x minus 35 equals 0. Now we can actually use the zero product property and factor the quadratic, factor this trinomial. x times x would give us x squared, and then we're looking for factors of 35 that differ by 2. So factors of 35 would be 7 and 5. Those factors differ by 2. Notice it's a negative 2x, so we want the negative to go with the 7, the positive to go with the 5. And so based on our factors, either x plus 5 must equal 0 or x minus 7 must equal 0. That would mean x is negative 5 or x is positive 7. Let's take a look at one last example to finish up here. Once again, in order to use the zero product property, we need to actually have 0 on one side of the equation, which we don't. So we're going to subtract 12 from both sides of the equation, and this will give us 2x squared plus 5x minus 12 equals 0. Now we can actually factor the trinomial, and the factors of 2x squared would be 2x and 1x. And then for factors of 12, we need to think about all the different pairs of factors for 12. We have 1 and 12, 2 and 6, and 3 and 4. Let's start by eliminating the 2 and 6 option. And the reason I say that is we'd have to have a 2 here or a 6. And because there's already a 2 in this set of parentheses, that means there would have been a greatest common factor of 2 that we could have factored out of the original trinomial, and that's not the case. So we're definitely not using 2 and 6. And if you remember in class, I mentioned that if you have pairs of factors and there's 1 in the original number and then other pairs of factors, usually it's not going to be 1 in the original number. So let's try 3 and 4. But I don't want to put the 4 here with the 2 because once again there would have been a factor of 2 I could have pulled out. Let's put the 3 with the 2 and the 4 here. And let's try a plus 4 and a minus 3. Let's just double check our middle term. 4x, or 2x times 4 would give us 8x. Here we'd have negative 3x, and when we combine those we would get positive 5x. So our two factors end up being 2x minus 3, and we would set that equal to 0. Or x plus 4 equals 0. This one's pretty easy to solve by subtracting 4 from both sides. This one we'll have to actually do 2 steps to solve for x. We'll add 3 to both sides, so we'd have 2x equals 3, and then to get the x by itself we'll divide by 2. So there we'd have x equals 3/2. We will continue to look at solving equations by factoring in class tomorrow. Don't forget to do the questions at the tiny URL related to this screencast.